Hello, my name is Purna Bahadur Mokhtan Lama. Today I'm going to present Interactive Advanced Concept Presentation 7. The topic name is Magnetic Fluid. In these presentations, I'm going to explain how the magnetic fluid or ferrofluid occur. Um, Basically, I have a two-step. In first step, I will explain theoretical aspects of magnetic fluid, and in second step, I will demonstrate. I will practically demonstrate how the ferrofluid occur. So, in first step, I'm going to explain about ferrofluid basic concept like. What is the ferrofluid? Ferrofluid is a liquid which becomes highly magnetized in the presence of a magnetic field, and these fluids are the stable colloid solution of nanomagnetic particles which infused with carrying fluid, usually water or organic solutions. If we explain about the history of the compound, it was invented by the NASA scientist Steve Pepele in 1963. The objectives of developing ferrofluid was to create a rocket fuel that could flow toward the fuel pump in the absence of gravity by implying a magnetic field. And the first confirmed applications of ferrofluid was during the Apollo moon landing mission. This is only the basic. I have explained the history of the compound. So, how does the corrugation occurs in the ferrofluid? The formation of corrugations in the ferrofluids lower the magnetic energy of the system but increase the gravitational and surface free energy. This effect occurs because the fluid contains microscopic magnetic particles which are up to 100 times smaller than the wavelength of the visible light. So when the force within the ferrofluid are balanced, it reaches a minimum energy state, and due to their high magnetic susceptibility, ferrofluids can form peaks even with a small bar magnet. So this is the process. How does the ferrofluid occur? So we can see here the structure of the ferrofluid, and there are mainly the two types of the ferrofluids. One is surfactant ferrofluid, and another is ionic ferrofluid. So in this composition of a typical ferrofluid is about 5% magnetic solids and 10% surfactant and 85% carrier by volume. Particles in the ferrofluids are disposed in a liquid, often using a surfactant, and thus ferrofluids are colloidal suspension materials with properties of more than one state of matter. Generally, the size of single domain magnetic particle lies between 5 to 10 nanometer, and the magnetite is sometimes like Fe3O4 or hematite is Fe2O3. So I have mentioned some basic properties of the ferrofluid, like the magnetizations, how it is occurs when the ferrofluids align with magnetic fields due to magnetic force, but revert to a random state once the field is removed due to thermal agitations, and magnetic fields affects ferrofluid viscosity by causing particle alignment, known as the magneto-viscous effect. When exposed to strong magnetic fields, ferrofluids display surface instabilities, transitioning from a flat surface to a hexagonal spike pattern known as Rosenzuik instability. These patterns optimize the system's magnetic and surface energies, and minimizing the magnetic energy at peak and valley and surface energy on the flat surface. So this is the how we can see during the formation of the um, ferrofluid. So this is the structure which I'm trying to show in practical demonstration stage. So we can see like the ferrofluid spiking, and some other important applications like ferrofluid can use in drug delivery or magnetic hyperthermia. Um, these are very beneficial in the case of medically, and some I would like to conclude the ferrofluids show great potential with growing application in space, medicines, and industry despite limited research. Current challenges include the absence of model for ferrofluid bearing and issue with ultral informations, and ferrofluids could suitably improve robust armor body. So this is my the first step, how the ferrofluid occur and what is the properties and how can we take the benefit from the ferrofluid. And in the next stage, I'm going to uh, practical. I'm going to show the practical demonstrations how the ferrofluid occur. Yeah, thank you. Hi, this is my second step. So in this step, I'm going to show how the ferrofluid occur in these practical demonstrations or presentations. First of all, I'm going to show my components. Like this is ink toner, which is very expensive, and vegetable oil, and I have normal magnet and some glasses and measuring teaspoon. So let's begin the experiment. I'm going to put this toner. First of all, toner, I'm going to put the 50 ml in the glass. Yes, this is the 50 ml. I have poured in the this. I'm going to put two teaspoons of vegetable oil, and I will try to avoid thick. Yes, one, two. I'll put a little bit more to make thin. Yeah, three. And it in like this, and try to close first of all my this. Then I will stir very nicely. Nice. Gently. Yes. More. Then I will pour gently in this clear and I'll try to do this. Yeah, you can see this pipe. See. How to sew? I cannot show the more spice like in video whatever you show, uh, but I saw gently. Yes. uh, in this experiment, um, I cannot show more. Yes. uh, I try my best, but I cannot see ferrofluid, and I'm very upset because I have invested a lot of, but again I'll try to see. I cannot see like that spike. Yeah, it might be the region. uh, it might be the two region behind this. First of all, there will be, I think, less um, iron oxide in this toner, because this is a new modern of the, or new generation of ink bottle. I think there is less content of the iron oxide in this toner, and another reasons might be I have a small one um, magnet, which is not a neodymium magnet. Maybe these two regions, I cannot success my uh, um, presentation, my demonstrations, but the things we need to do in this way only, um, and and how it occurs, what is the properties, and how we can perform the ferrofluid. I have already explained in previous theory first stage topic. I think this is okay. Thank you so much.